This problem is about finding the LMTD between tank contents and a coil fluid. Let us read the problem statement. An organic liquid is cooled continuously in a stirred tank by water flowing through a cooling coil. The organic liquid may be considered to be perfectly mixed. Inlet and outlet temperatures of the organic liquid are 50 degrees Celsius and 30 degrees Celsius respectively, and those of the cooling water are 20 degrees Celsius and 25 degrees Celsius. Calculate the log mean temperature difference in heat transfer through the coil. Okay, that is the problem statement. Let us represent the temperature profile. Before that, let us represent the schematic of the vessel. So we have a stirred tank, otherwise there is a stirrer which is making the entire contents of this tank contents at uniform temperature. So the tank contents are at a temperature of, otherwise the leaving temperature and the tank contents temperature are the same. Otherwise this is like our CSTR in our chemical reaction engineering, where the leaving concentration and the tank content are at leaving fluid and the tank contents are at the same concentration. So otherwise the leaving fluid is at 30 degrees Celsius. So the tank contents also are at 30 degrees Celsius. This is so this entire contents are at 30 degrees Celsius because of the uniform perfectly mixing by the stirrer. Okay, this is a stirrer, and here we have a fluid which is entering at 25 degrees Celsius and it is catered to this fluid at 20 degrees Celsius is for cooling these contents. This coolant is entering at 20 degrees Celsius and getting raised its temperature to 25 degrees Celsius. This is passing through a coil. Okay. Now let us represent the temperature profile of this setup. So here the tank content is entering at 50 degrees Celsius, and as and when it is entering to the tank, the entire tank is at the uniform temperature as that of the leaving fluid temperature. So the leaving fluid is at 30, so entire contents are at the 30 degrees Celsius. There is a sudden change in temperature from 50 to the leaving temperature, or is the entire vessel is at the leaving conditions. Okay, leaving condition is 30 degrees Celsius. So, and the coil fluid, which is a tubular arrangement, so the coil fluid is entering at 20 degrees Celsius and leaving at 25 degrees Celsius, for which there is a progressive change in temperature. So this is like a plug flow for which there is a progressive change in concentration in the case of our reaction engineering. So here there is a progressive change in temperature, whereas this tank, which is a CSTR one, for which there is a sudden change in concentration, as like that we have a sudden change in temperature. So once we draw this temperature profile, we can easily say the temperature difference at these ends. So temperature difference at this end left side is this 30 minus 20, we have 10 degrees Celsius drop change in one end, and in the other end the temperature difference is 30 minus 25. So this is the available temperature difference, or is between maybe what is it, this is entire, this is the 30, say this is 30 and 25 between this tank fluid and the leaving fluid, and between the inlet and tank fluid, that is at 30 and this is at 20, or is this one. Okay, fine. Now so we know that delta T at one end and delta T at other end, which is simply only 5 degrees Celsius. This is to be noted very carefully. If you do by mistakenly, otherwise if you don't consider this sudden change in temperature, you would use simply this delta T of 50 minus 25. Otherwise for this end you will take this delta T of 25, and for this end of course 10 degrees Celsius. So the delta T mean will be actually you will be estimating to be a higher value, whereas the actual delta T possible in this stirred tank vessel heated by a coil fluid, stirred tank vessel cooled by a coil fluid or heated by a coil fluid, is having this kind of sudden change in temperature for the tank fluid and progressive change in temperature for the coil fluid. So here we have delta T at one end, which is 10, and delta T at other end, which is 5 degrees Celsius. So 10 minus 5 divided by ln of 10 by 5. So we get this as 7.21 degrees Celsius. This is the correct answer. So the correct answer is 7.21 degrees Celsius. Whereas if you do by mistake, that is, if you take this delta T as this 50 minus 25, the value you estimate will be higher than this, maybe somewhere around some 10 degrees Celsius or still higher. Okay, so that is wrong. So you should draw this temperature profile carefully, considering this well mixed tank. For the well mixed tank, there is a sudden change in temperature. Okay, thank you.